Okay.
I just don't like
Simplifying radicals with variables.
Today's the 19th, right?
Right?
Yes.
Okay.
So you know how to now simplify them with numbers. And that's awesome. It's a great, I mean, it is awesome to know how to do it. It's kind of fun. It's sort of like a puzzle. I didn't really explain this to you, but in all honesty, this was developed, the method that we've been working on, simplifying radicals, it was really developed back in a time before we had calculators. I was actually alive when calculators were first invented, the home calculator. I was actually, I was a kid, and my dad had turned, I don't know what he turned, like 40, and for his 40th birthday present, we bought him a calculator. It was the first home calculator available for sale. It was this big, it was this high, this big, and this wide, and all it did was add, subtract, multiply, and divide. That's it.
This is now.
And the 99 cents,
What? It
the
was
99
like that?
cent specials at Walmart do more than that one did, and it cost us over $300 for that little calculator.
He's almost 60.
I'm almost 60. I don't like that. I'm way before 60. I'm around 57 and 3/4.
Whoa, you're like.
Shush, boy.
You're old,
Still in your
man.
prime,
Right,
Gary.
right.
You're so old.
You're in your prime.
Brian.
You don't look a
Yeah, I'm
day
in
over
my-
31.
Thank you. You get
Totally
an A.
not in your
We're
20s.
good.
You don't look a day over 90.
But guys, listen up.
Totally.
Guys, shh. This is actually interesting. This is actually interesting. When simplifying radicals were created or figured out, the reason why was because we didn't have calculators to give us what is the square root of 2, or what's the square root of 33, or what's the square root of anything, right? We didn't, if they weren't perfect squares, we didn't know what to do, because we didn't have calculators to do it with, right? We did have computers back then, but it was a mainframe computer. This whole room was filled with the server, right? I mean, it was like, that was what, we had a computer room that was just one gigantic, conglomeration of computer
And
stuff.
now you look at iPads
Right?
and it's like more powerful than the first computer.
No
Oh, yeah.
phones.
It's
And it's like,
it's
oh.
huge. It's huge, the progress we've made.
Becca.
But understand,
Becca.
since we, guys, come on. Since we didn't have these, what we had in the back of every math book, guys, listen, at the back of every math book, you had tables and tables and tables of square root of 1, square root of 2, 1 point da 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 da, and square root of 3, 1 point da 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 da, square root of 4, 2, square root of 5, 2 point da 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 da, right? And it would all be rounded to the fourth decimal.
So did you just have to memorize them?
And so what happened is we memorized them. But we didn't memorize all of them. We would memorize the simple ones, right? We would memorize the square root of 2, and we would memorize the square root of 3. Who made them? I don't know.
And how would you figure out a square root if you didn't know?
You'd have to do elimination.
I don't have enough time to answer that question. But
2.5 times 2.5.
But you can certainly do trial by error, right? And 1.12 times 1.12,
Gary, that would take forever.
it would take forever. There are other ways, but that's one way you could do it. But my point is, in order to simplify a problem, if I had the square root of 32, right, I am not going to memorize, I'm not going to go to the 8th page and find out what is the square root of 32 and memorize that. I am going to simplify that to the square root of 16 times the square root of 2, which means suddenly 4 times the square root of 2, I memorized the square root of 2, 1 point something, right? So then I could figure out an approximate answer. Does that make sense? But nowadays, it is, which is faster? If for me to go the square root of 32 on the calculator, 32 square root, I've got the answer. I'm done. I don't need to spend all my time simplifying the square root of 32 into 4 times the square root of 2, right? You see what I'm saying? Back then I did because it was so much easier mathematically to do things longhand, because that's how we had to do it. Because I had to multiply numbers times those
What if you had
4-digit decimals.
calculators and
So now that we have calculators, technically a lot of what I'm teaching with the radicals, with the numbers, with the simplifying, is sort of ridiculous.
Yeah, why are we taught algebra? The majority
Well-
of calculators.
Well,
can
so you
solve
know
everything.
how to actually do it on a calculator.
Yeah, a lot of things you have to understand the concept behind them, right? Otherwise, you know, if you don't know the concept, you won't have not even how to use the calculator.
Yeah, besides
Ah.
opening new ways to think is.
And it is, and each time you open to a new way of thinking, you are actually, your dendrites and neurons and everything in your brain are actually growing. And they're intertwining around things, and suddenly you actually have sparks of awareness and understanding that you didn't before, and you actually become smarter. So even though learning the quadratic formula may not be something you end up using in real life, by using and by learning the quadratic formula and learning how to use it in life,
That makes you smarter.
it makes you smarter and more able to actually solve complicated problems in real life. You know what I'm saying? Because you have more mental facilities, more mental faculties to use. And so, you know, do I think everybody needs Algebra 1 and Algebra 2? And no, to be honest with you. Have I used everything that I teach in real life? No,
No.
I haven't. Does it piss me off? No. I actually enjoy some of the stuff that I don't do in real life. Does it make me upset? No. This is a lecture on video. Okay.
Here's the YouTube movie editor.
Don't ever use that word again, young man.
What?
God,
What?
Gideon.
Okay. So anyways,
shame.
so anyways, it's interesting, but the truth is, you will actually be tested on this stuff in your when you go to high school, and you have PSATs and SATs and ACTs. They will ask you to simplify these things. So even though technically it's sort of a ridiculous skill at this point, it's sort of not needed. You still need to learn it at this point, right?
Stuff with 7 minutes.
Oh God. All right, but fortunately, what we're about to do is really pretty easy.
Yay!
I'll try to remember to actually write it down this time.
The square root of x squared. So
What?
remember, what is a square root? A square root is of a number is you're looking for a number that times itself equals the number under the square root sign. What would that be?
Just X.
Yeah. What's x times x? X squared, right? So x squared, the square root of x squared is x times x. You guys agree with me, right?
No.
Right? Yes?
Yes.
No? You get that?
Yeah.
Go ahead.
Wait,
Is
what if it's just
Wait a minute. Just hang on.
are exponents to square roots as dividing as to multiplying? And adding
Yeah,
as
very good question.
subtracting?
It's basically the opposite.
Yeah.
Square root is the opposite of a square. That's really perceptive. That's really a perceptive comment. Really perceptive. So, you guys agree with me? Remember we talked about a square root says you have to have two of the same thing for them to be crossed out and come outside, right? So look at this. I've got two x's. Crossing them out. It comes out as an x, so my final answer is x. There's nothing left over inside. Square root of x squared is x to the 1 power. I don't have to write the 1, but I just want you to see that for a second. Do you notice anything between this, the square root of x squared, and the square root of x to the 1?
why do you need the X squared in there?
Well, that's the problem I gave you.
Oh well, like
So-
I mean, like, what if it was just like the square root of X?
Yeah, but good question, but I'm not there yet. Let me just keep going. Let's say we have the square root of x to the 4th. What number times itself would equal x to the 4th?
X
X squared.
X squared. So really, that's the same as x squared times x squared, right? You guys all agree with me? Using exponent rules, same bases times with exponents.
And then
You
you
add the
cross it out,
exponents,
and
right?
it equals X
you cross them out, and it comes out as an x squared, so your answer is x squared. Now that's
Yay.
interesting. The square root of x to the 4th is x to the 2. That's interesting.
Because it's
Just
still
notice
using-
patterns, okay?
So you
Square root of x to the 6th. What number times itself equals x to the 6th?
3 times 2.
No.
Think about it.
Oh, would it be x times x to the 3rd?
Wouldn't that equal x to the 6th?
No.
What's
Yeah.
x to the 3rd times x to
Yeah.
the 3rd is x to the 3 plus 3,
Yeah,
which is
would.
x to the 6th,
Good
right?
one.
So there's my 2 again. That comes out as x cubed. Now look, the square root of x to the 6 is x to the 3.
just cut it in half.
You see that pattern?
Cut it in
The
half.
square root cuts the exponent in half.
What about x5? X to the 5th power.
Okay, we'll get there. We're gonna get there.
It'd be
Let's
x to
do
the 2.5.
now. Let's do one a little harder. X to the 22.
X to the 11th.
Yes, it's gonna be the x to the 11th. All you're doing is you're cutting the exponent in half. The square root cuts the square, the exponent in half, right?
Yeah.
What if it was the square root of x to the 144th?
Half of that.
It is
72.
72.
X to the
So
72.
Thunder.
Half of this, right?
God. So mean.
Right? So now somebody asked, who was that? Just asked about the, was that Ben?
Yeah.
You had
I
asked
forgot x to the 5th.
about x to the
What
5th.
did you die?
Actually, and actually, ironically, Mira asked a question too. I'm going to answer Mira's question first. She asked, well, what if you just had the square root of x? Well, ironically,
It's just this
square roots are actually exponents. And this could actually be written as this. X to the 1/2 power. Which is interesting. Think about it. What if you had, let's take this one, x to the 6. X to the square root of x to the 6 is the same as x to the 6 to the 1/2 power. Isn't that interesting? Now look at that. When you have exponents with a parenthesis between them, what do you do with them? Parenthesis always means multiply, right? So what is half of 6?
3.
Ah, x to the 3rd. Look at that. That's why, Mira, I'm answering your question. That's why we're taking the square root of x is the same as the square root of 1 over x. This is the 2, and this is the 1. So the 1, the exponent on the x goes here. This number here goes in the denominator, right? So anyways, just so you know, that is technically the reason why what we're doing is working, right? Now, let's look at Ben's question. He said, what if it was the square root of x to the 5th? So if it's an odd number, obviously there's not one number that works. Do you agree with me? I mean, there's not, I could say x to the 2.5, right? Times x to the 2.5,
2.5.
right? I could do that. That is one way, and some people do choose to do it this way. Let's just try it that way. X, so that is the square root of x to the 2.5 times x to the 2.5. Now that's not necessarily what I would recommend, but it is a way that some people do it. So think about it. That would mean it would be x to the 2.5. The only thing is, you don't ever leave a exponent in a decimal when you're simplifying this. So,
If you just do x to the 5th in parentheses times 1/2.
well, wait. Really, this is the same thing as x to the 2 times x to the 0.5, which is 1/2. Do you agree with me?
Yeah.
Right? You
Why
agree
don't
with
you
me?
just change it to x
So
to
what's the
2
square root of x to the 2?
Hey, wait, Gary. What if you were to
Right.
just change the decimal to x 2.5? It wouldn't be in a decimal technically.
Right, okay, well, hang on. What's the square root of x squared? X. And what it, oh, wait a minute, what am I doing?
You're right out of time.
So, anyways,
Um,
I'm running out of time, so I'm going to teach you the way I would recommend you do it. So if you have the square root of x to the 5th, let's rewrite it as something that has an even number exponent. So let's rewrite it as this. X to the fourth, 1 less than 5, times x. You with me?
Yes.
Now, what's the square root of x to the fourth?
X to the second.
So that's going to come out as x to the second. So I have x to the second, and then this doesn't have a perfect square, so I'm going to just say square root of x. Right? You see what I'm saying? So let's just try just a few really fast. Really fast.
Too late.
Too late.
Faster. You could take a picture.
Too late.
He
Alright.
said don't erase it like right before he started, so.
Square root of x to the 9. Square root of x to the 9. Help me, guys. Everybody
I'm
together.
taking a picture.
X to the square root of 8 times x.
Which is equal to x to the fourth times the square root of x.
Yeah.
Right? All right, here's another one. Square root of x to the, sorry, hang on. X to the 11th, y to the 9th. So, square root of x to the 10, x times x, y to the 8th times y. So what's the square root of x to the 10? X to the 5. And then what's the square root of y to the 8th? Y to the 4th. And then inside I have my x and my y. Right? All right? Oh, we are over.
Oh,
Okay.
wait 1 second. Now I gotta
Let's
write
try.
it down.
Pretty straightforward.